So let's try to solve practice problem 1. So given an ideal gas at 300 Kelvin, has a volume of 15 liters and a pressure of 15 atm, calculate the final volume of the system, the work done by the system, the heat energy or leaving the system, D, the change in the internal energy, and E, the change in enthalpy when the gas undergoes a reversible adiabatic expansion to a pressure of 10 atm. 10 atm. The constant volume molar heat capacity of the gas is 1.5 R. So given that, it's always convenient for us to write what is given first. Then we can find things from the given na kaya nating malaman. So first, ang una kong ginagawa is I identify the states that we'll be using. So meron lang naman dito tayong initial and final state. So I name this state 1 and state 2. And it is convenient for us if we identify the state variables for each of the state. So pressure, volume, and temperature. Pressure, volume, and temperature. And we can also identify one other state variable, N, or the number of moles for our system. The number of moles, N, can be obtained from your ideal gas law. N is equal to PV over RT. Since from the ideal gas law, you have PV is equal to RT. Using that, P is 15, volume is 15, yung ating gas constant is 0.08206 liter atmosphere per mole Kelvin, and your temperature is 300 Kelvin, you would get that your N, or the number of moles, is 9.14. Then, we can now look for what is nawawala. So first, let's look for A, the final volume of the system. The final volume of the system can be obtained from the relation that we got for the adiabatic expansion, which is P1 V1 gamma is equal to P2 V2 gamma. We have P1. P1 is 15. Volume of state 1 is 15. Gamma is equal to Cp over Cv. We know for an ideal gas, Cp is equal to Cv plus R, which is equal to 1.5 R plus R, or equal to 2.5 R. So this would mean gamma is equal to 2.5 R over 1.5 R, or equal to 5 over 3. So this will be 15 raised to 5 over 3 is equal to P2. P2 is 10 atm. And your volume 2, yan yung hinahanap natin, V2 raised to 5 over 3. You can isolate for V3, and if you solve this one, you can just use any of our equation solvers or your calculator. We can get V3 is equal to 19.13 liters. So this is V2. Now B, to get the internal energy, the work done by the system, we just need to get, we know for the adiabatic expansion that Q is equal to 0. So if Q is equal to 0, this will mean that delta U is equal to negative W. Or W is equal to negative delta U. For delta U, we know for any ideal gas that du is equal to Cv dt. Nakita niyo ba kung saan tayo pupunta dyan? If du is equal to Cv dt, then that would mean delta U is equal to Cv delta T. And pag meron tayong number of moles in a gas, we just multiply this by N. So then this will mean that W is equal to negative delta U, which is equal to negative N Cv dt. Work will be equal to negative N 9.14 Cv, since Cv is our molar heat capacity, kaya multiply natin 9.14, 1.5 times 8.3144 joules per mole Kelvin. Then we have delta T. Yung delta T natin, that is T2 minus T1. We have T1, 300 Kelvin. Now we must look for T2. To get T2, T2 can be obtained from the ideal gas law. PV is equal to nRT, or you will have P is equal to P2 V2 over nR. P2 is 10, V2 is 19.13, N is 9.14, and R is 0.08206 mole atmosphere per liter atmosphere per mole Kelvin, and we'll get T2 is equal to 255 Kelvin. So dito, so work will be equal to negative 99.14 multiplied by 1.5 times 8.3144 times 255 minus 300, or your work will be equal to 5,130 joules approximately. So that's B. For letter C, what is the heat evolved? Since heat for an adiabatic expansion is equal to 0, then C, Q is equal to 0. For letter D, what is the change in internal energy? We already established that delta U is equal to negative W. So this would mean delta U is equal to negative 5,130 joules. And for letter E, we're looking for the change in enthalpy. For the change in enthalpy, delta H is just equal to N Cp delta T. Similar kasi kanina, that dH is equal to Cp dt. So integrating that, we just get this relation. So please recall that ito and ito, expressions for delta H and delta U, relating Cv and Cp to them, is always valid for any ideal gas. Then we have ito, delta H will be equal to 9.14. So be equal to 9.14 times Cp. Yung Cp natin would be equal to 2.5 times R, which is 8.3144. And you have delta T, which is 255 minus 300. And getting the solution to that one, so for that, using your calculator or whatever na kaya nyo, you will get negative 8,549 joules. So for A, our volume is 19.13 liters. Our work done is 5,130 joules. The heat flow is 0. The change in internal energy, delta U, is equal to negative 5,130 joules. And your change in enthalpy, delta H, is equal to negative 8,549 joules. So thank you, and on to the next problem.